you are ready for your talk.
I am ready. Can you hear me?
Fantastic. Yes. So
Good.
Dimitri will explain database for an expert system. Very interesting. So go ahead, Dimitri.
Yes, thank you. Unfortunately, I'm on another device, so I have no camera, but I will be doing lots of screen sharing. So let me share my screen from now, if I can. Okay. And what I'll try to do is tell a bit of a story about how I started looking into this expert system thing. So some of you might remember when I presented before on a Prolog being implemented in Forth, and you may have seen my posts on the Facebook group. Now, the objective of this was to try and explore certain parts of artificial intelligence using Forth. So I worked on reviving this old implementation of Prolog in Forth, and I managed to get what was written in that paper to run. So I was pleased. And what the author had done is he had used Prolog to implement expert systems, right? So you have an expert system which is implemented in Prolog, which is implemented in Forth. And the advantage was, since Forth can run on devices with limited memory, you'd be able to have an expert system on your device. Now, for those who perhaps don't know about expert systems, it's one of the approaches of symbolic AI in the past. And the idea was that if you could put someone's knowledge into a computer and then guide a user through questions, it could be like having an expert working with an inexperienced user. So the computer has all the knowledge, it tells the user what to do and why it thinks certain things should be done and so on. One of the most common examples is actually for medicine in the medical world. Even as of recently, I had some pain in my ear. And I was like, well, this is bad. I need to go to a doctor. So I go on the app and I have to answer all these questions, right? Now, these questions don't get sent to a human because within seconds of filling out those questions, you get a response to say, you probably have this, and the reason we think that is blah, blah, blah. What you need to do is so and so, which is reasonably intelligent, right? So I thought, great. So I began looking into Prolog and expert systems, and this was the book that I refer to. I don't know if you can see that. Okay, building expert systems in Prolog. It's respected by many people, and it helped me to learn about these things. You know, you've got backwards chaining systems where you know what the result is going to be, such as with an illness. So, you know, common cold has certain symptoms, so you can identify it by the symptoms. But there's also another kind called forward chaining, where what you do is you don't know what the result is going to be like, but you have rules that guide the process. So say, for example, designing a PCB, printed circuit board design. Now, you can't say, based on these components, this is exactly how the result should look, but you know that the result is going to conform to certain rules. You know that there's going to need to be certain capacitors on certain pins. You know that certain tracks need spacing, and obviously you need to make sure that wires don't touch that shouldn't be touching. So that's a little bit of an overview of expert systems. Now, I was really sold on this idea until I got to the appendix, which I'm just scrolling to now if I can, and I saw the engine that was being used. So this is the engine written in Prolog for an expert system that is with the book. And what I can tell you basically is this uses some concepts in Prolog that are considered unclean, like the things that you're not really encouraged to do. I looked at this and I thought, I was expecting Prolog would allow you to construct an expert system more easily. I was a little bit disappointed. And so I looked at a tutorial from my teacher who's been teaching me Prolog. And again, first thing he's saying, use a domain-specific language. And he shows that, and it's not extremely hard, but it wasn't as simple as I expected. So then I said, well, why not just implement an expert system language in Forth? And that's what I did. And that's what I have on the left here, in Forth Win. And I will guide you through this to explain how this code works. It's very simple, right? It's actually very simple, the functionality. Some of the ways I've expressed things could be simplified, but we'll come back to that. So the resulting program looks like this, right? So ignore the first few lines, go to the database. Now, I understand that COVID-19 can be a bit of a sensitive issue for people. So please don't see this as a fact, or don't see this as a medical advice. It's just for illustration. I did use this when I became ill some months ago, and I actually was able to diagnose myself. But please, if you're unwell or have concerns, see a doctor. So what we have here is a language that I've created essentially in Forth. And what the system will do is ask you questions. Now, if the answer to those questions are yes, then you know the diagnosis. For example, COVID-19, the Delta variant, has these symptoms. COVID-19 Omicron has a different set of symptoms. And common cold has another set yet again. So I'll show you how you use it. All you do is you type in solve, and okay, that's because I haven't loaded the script. Let me just run that. I'm just double checking that everything is as yes, this should be correct. Okay, right, solve. And see, it starts asking you questions, okay? And all you got to do is answer those questions, and then you'll find out what you most likely have. Now, I actually did this, and so I'm just trying to find my record of when I filled it out. Yes, here we go. And so it asked me this: slow build of symptoms. Yes, it took a few days. Do I have headaches? Yep. Sore throat? Yes. Runny nose? Yes. Fever? My temperature's fine. I don't have a fever. Okay, no. Cough? Yes, I have a cough. Fatigue? Yes. Really, really tired. Tiredness? Yep, exactly. And congestion? Yes. And this was an interesting one. No loss of taste or smell. Because some variants have this, some don't. In my case, it was yes. And there you go. It tells you COVID-19 Omicron. So this is a simplified example, of course. It only has a few illnesses in the system, but for a hospital, this could contain, say, all of the most common kinds of colds, infections, and viruses. And you can automate some of the process, rather than the patient having to take up a doctor's time, they can fill in some answers here. The computer will then refer them to the right person. For those who are building robots and other things, this could be a system that a robot uses. The robot could be probing its environment, asking questions about it. Is there a wall here? Is there a wall there? And perhaps even the robot can diagnose something that's wrong with itself. So how does this work? What allows me to write in this language here, which doesn't even look like Forth? I mean, this looks more like Prolog than it does Forth. Well, let me show you. Simple expert system language. I define a constant. And then on the next line, you see the really, really key part, create. Create is a word that allows you to basically define your own data types. I would say it's the version of data types or structures that is built into Forth. Of course, you can implement C-like structures in Forth as well, but create always exists in implementation, as far as I know. And what we do is we define in this word question. It's a data type. It's going to create something in a dictionary with 2 spaces. One is for the answer to the question, and the other is to say whether the question's been answered before. If a question has been answered before, we don't want to ask it again because that's tedious. Why do this? You could have thousands of questions in your database. You want to be efficient. This here is just an accessor word. So I've kind of quickly formed my own struct. So this just says basically that this slot here is the one that contains the answer. So the one before must say whether it's been answered before. And we define some other words too. So dot question prints out the question. It uses this word, which is Forth2020 specific, but there is usually a way to do it in your Forth implementation. What it will do is it will take the address of the question and it will find the word, okay? So say, for example, you pass it slow build of symptoms. That goes on the stack. In fact, let me show you. That goes on the stack as an address, okay? But if I do word by address, it manages to find the words that corresponds to that address. So it's just a very easy way of implementing symbols, all right? This, I think, makes Forth as powerful as Lisp. So I'm very keen on this concept. This is just to interact with the user, asking them yes or no questions and updating the database. And after that, we get to the idea of rules. So again, you can see here a similar thing. I'm creating a data type called rule. A rule contains questions. Okay, so COVID-19 Delta is a rule. It contains questions, which are defined above. And essentially what the algorithm is, so notice here, I've even got a colon and a semicolon. I try to mimic the syntax of Forth, but I'm creating my own language. I'm not writing in Forth by the time I finish this. So the real engine of it starts here, and it's 2 very difficult to parse words. I'm looking at rewriting them because it doesn't have to be done this way. But the basic concept is this. When we prove a rule, what we're doing is we need to ask it. We need to ask each question. And when a question is answered no, we finish. We stop asking questions because it means that this rule doesn't apply. So if you're identifying COVID-19 Delta and your answer to slow build of symptoms is no, well, then it's obviously not COVID-19 Delta, so it might as well move on to the next rule. This is expressed by this Boolean value. So you ask each of those questions until it gets to the end. It will give you a Boolean, yes or no. Did you prove it or did you not prove it? And then the layer on top of that is solve, which is essentially doing the same thing for each rule. So while prove asks the questions within a rule, solve is going through all the rules until it finds the rule that matches. And what I've done just before this meeting is I've experimented with creating this new word here, more rules, because it used to just say this. which is meaningless, but more rules make sense, you know. If there's more rules and something else, then you want to prove each rule. Finally, when we get to the end, we give the answer, which is done by a little bit of arithmetic at the end, and using my favorite word by address word, and you type it out. So as you can see here, in how many lines is this? Maybe that's about maybe 15 lines, 10 or 15 lines. I'm just doing it at a glance. You can write a program that looks nothing like Forth. It's your own language to solve your problem. And what I'd expect from a user is that they would take, it's the database really that they would create for their program. And I actually did this because the original database was just an animal identification program. It just said, it asks questions and it identifies, is it a duck, is it a bird, is it a snake, you know, that kind of thing. But I said, that's not a very practical example, so let me come up with something more practical. And so I rewrote the database, which is simply a case of adding the right questions and rules for different illnesses you can have. So that is my expert system. It is on GitHub. Here it is. So I will give you the link to this for anyone who's interested. If you are concerned about running it, you just want to run it. Again, if you just search for Forth2020, you can now have this Forth2020 setup script. I'm on a new machine here. I ran this script and installed Forth2020 just before the meeting. So it's very easy to do. You know, if you're new to Forth and you're testing this out, or you just run it without problems, go this way. If you're trying to port it to another system, feel free to get in contact with me, as like Francois did, and I will help you to implement this. So I understand I'm a bit running over on time, but just to give a final sort of comment, I'm looking to rewrite this, however, because I don't like the idea of iterating over some code and interpreting it. That's essentially what I've written an interpreter. I figured, why don't I just use colon? Colon does exactly that in Forth. So what I would do instead is I would make a question able to ask itself, which is what I'm experimenting here. So questions ask themselves, and all a rule would be is a colon definition, you know, rule Q1, Q2, Q3, and let Forth iterate through that list. This should simplify the program and make it easier to run on more devices. So stay tuned, because that's something I might attempt doing. And at this point, I'll open to questions.
Excellent, Demitri, fantastic.
Thank you very much.
I need to say that I used an expert system myself in the late 80s for the CNC machines. I detected that customers were asking all the time the same questions, first-time customers. And I implemented this also in Forth, but my system was huge, was not so well designed, so simply as Demitri did. I am very, very happy to see that. And also, this second part Demitri is explaining us is exactly what people should learn about Forth, that Forth is full of tools. And when you are clever, you can tweak these tools and have almost no code. Forth programs almost itself, but you need to be clever.
I would say it's the like sort of more advanced level of Forth, but when I say advanced, I'm only speaking from the perspective of all programming, right? As someone who's learning Forth, you can actually be introduced to this probably fairly early on and grasp it. But in terms of thinking this way, this is what I think makes Forth very different, and one of the reasons why I liked using it. I couldn't see myself creating a language like this in something else. I'd probably write an interpreter, but here I've not written an interpreter. I've just extended Forth. So